In this video, we will learn how to write an assembly language program to enter and display 8-bit numbers. So the first line of our program is dot model small. So it indicates that our all data and our all code are stored within only one program segment. Now here we have declared the dot data segment, that is our data segment directory. In that we have declared these two variables, that is message1 and message2. These two variables are in the 8-bit format, that is 1 byte of data will be declared with the help of these db directives. So we have written here message1, then db 10, 13, enter 8-bit numbers, and this string will be ended with the $sign. Whenever we have to declare the string, we can declare it as db directive, or either it can be declared it as dw directives. Here we have declared the string with the help of these db directives. And always we can end our string with the help of $symbol. While declaration, we have used this 10, 13, these two numbers we have taken. So this 10 is the ASCII control code for the line feed, and 13 is the code for carriage return. So the line feed control code will move to the cursor to the next line of our code. So with the help of writing this 10, we can move our control to the next line of our code. And with the help of writing this 13, we can move the cursor to the start of the line of the code. So by using this 10 and 13 together, we can move the cursor to the start of the next line of our code. So that's why we have written here 10, 13 in our program. So now the next line of our code is dot code. So dot code indicates that is actual code segment, and we are declaring the program statement in our assembly language program. Now the next line is dot startup. So with the help of this dot startup, our all data segment and code segment will be initialized in our program segment, and our program execution will begins with that dot startup. Now we have written this move age, 09H, load effective address dx, message1 and integer 21H. With the help of these three lines, we are printing this message1 on our console. So for printing the data on our console, we have to move the value, that is 09H, that is our DOS interrupt, in our AH register. Then our value of our message1 will be loaded in our DX register. So we are copying the address of our message1 in our DX register. So load effective address, this instruction will be used for loading the effective address of particular variable into DX register. Then with the help of integer 21H interrupt, we will break our program and we are printing the message1 on our console. So in our console, enter 8-bit number, that will be printed on our screen. So now we have only just printed enter 8-bit number on our screen. We have not entered the number on our screen. So here there are some DOS interrupts that are used for taking the data, printing the data, as well as we are taking the data from the register, and that is also printed on our screen. So the first of all, the first DOS interrupt is 09H interrupt, and this DOS interrupt is used for printing the data on our screen that will be declared in our message variable. Now the next part of our code is move age, 01H and integer 21H. So these two lines are written for taking the data from keyboard. So that lines will be used for accepting the data from our keyboard. So this 01H interrupt is used for taking the input from keyboard. This one is for output and this is for input. So now let's see how this will be executed in our emulator screen. So here we have started the execution of our program, and our program execution will begins with this dot startup line. So once we are clicking on that single step mode of operation, then our value of our move age, 09H will be copy it into the age register. So here the contents of age becomes 09H, and load effective address dx message 1. This instruction will load the effective address of our message 1 into our dx register. So our dx register becomes 0000H. Then after using this integer 21H interrupt, our console will be display as enter 8-bit number. Previously, it doesn't consist of any value on our console. You can see with the help of this step back method. And I'm clicking now on the single step button. It will display enter 8-bit number. Now next one, move age, 01H. So after using this instruction, we can take the data from keyboard. So 01H will be copy it into the AH register. So whenever we have to call the DOS interrupt, that time we have to move the value of particular DOS interrupt into our AH register. So previously we have to print a value on our console. That time we have shifted the value 09 in our AH register. Now we are copying the value 01 in our AH register. With the help of integer 21H interrupt, we are requesting the data for keyboard, and we are taking this data from the keyboard and it will display the message as waiting for input. So now see here the line will be blinking here. So we have to take the data from the keyboard and we have to press any key from the keyboard. Suppose I want to take the number that is 23. So I am pressing here 2 and I can leave the control from my keyboard and I am clicking on that again single step mode of our execution. So now in our console we have only printed the data that is 2. We have accepted the input as a 2. We have not printing this data. We have taken this data from our keyboard. Once we are taking the data from our keyboard, that will be taken into the register. Whenever I am pressing here 2 from the keyboard, the data will be 32 and that will be there in our AL register. So now we have to subtract AL, 30H. So why there is need to subtract 30 from AL register? We require number 2, that is 02. But whenever we are pressing the data from the keyboard, that is 2, automatically the hexadecimal value of their number will be added and that will be displayed on our AL register. So our AL register becomes 32. So we require the number 02 for printing the value on your console. That's why we have to subtract the value 30 from AL register. So that we are using subtract AL, 30H. And after executing this instruction, it will become 02 in the contents of AL register. Now we have to copy the value of CL is equal to 04. So that's why we have written here move CL, 04H. Now the next instruction is SHL AL, CL. So what are the contents of now AL? That is 02. And what is the contents of now CL? That is 04. So you have to shift this 02 4 times on the left side. So now we will perform this operation. Now you can check that our 02 will be 0000 and 0010. So we have to shift this value 4 times on the left side. On the first iteration, it will become this 0 here, then 0, this 0, and and this 0. Again it will be 0, then 1, then 0 and this 0. Now on the second time we will get this 0, then 0, then 0 and then 0. Again 1, then 0, then 0 and 0. And in the third iteration we will get this 0, again 0 and again 0 and again 1. Then 0, again 0, then 0 and this will be 0. And in the fourth iteration, we will get our output as 0, 0, 1 and 0. And this will be 0, this is also 0, this is also 0 and here it is 0. So we will get our output it as 0, 0, 1, 0, 0, 0, 0, 0. So our value will be 0, 0, 1, 0 is equal to 2 and 0, 0, 0, 0 is equal to 0. So after performing the shift left operation, that is the instruction, we will get the contents of AL is equal to 2, 0. So now why we have shifted this value on the left side? We have to enter the number that is 23. So 23 is nothing but 20 plus 3. So that's why we have taken this 20 after performing this shift left operation. So now what will be the next step? We have to copy the contents of this AL into our BL register. And now our BL becomes 20H. Because later on we have to add this 20 plus 3 together. That's why we have copying this number 20 from AL to our BL register. Now the next part of our code is move h, 01h and integer 21h. So previously we have taken the input 2 from the keyboard. Now we have to take the input 3 from the keyboard. So that's why we have written these two lines in our program. So here you can check that when we are clicking on that single step mode of operation, our contents of our AL will be copied into the BL register. So now our BL becomes 20H. And now we are copying this 01H DOS interrupt in our AH register. And after using this integer 21H, it will be asking for the input from the keyboard. And it will shows the message waiting for input. And we are printing here, that is we are pressing here 3 from the keyboard and we are leaving the control from the keyboard. And now we have to click on that single step mode of our execution. Then it will be redirect to the next line of our code. Whenever I am pressing the 3 from the keyboard, the ASCII value of 3 will be added in our AL register. So whenever I am putting the data from the keyboard, that is 3, automatically the data register will be taken, AL register, and the hexadecimal value of the variable will be taken in our AL register. So now we require the number 3. We don't require the number 33. So that's why we have to subtract the 30 from AL register. So we have to write the instruction that is subtract AL, 30H. And we will get this value that is 03H. So now we got this two number that is 20 and 3. So we have to add this 20 plus 3 together, then we will get this number that is 23. So I'm clicking on that single step mode of operation and now the contents of AL becomes 23. Now we have to copy the result of the operation that is 23 on our BH register. So now the contents of BH becomes 23. So now what is the next instruction in our program? That we have to execute the next part of our code. So now we have taken here enter 8-bit numbers and we have taken this 23 from the keyboard. So one by one we have taken this number as a 2, then our 3 is there. Now we have to print this number on our console. So how we can print this number in our console? So that first of all we have to print the message 2 on our console, that is 8-bit number is. So for displaying the data on our console, we have to use the DOS interrupt, that is 09H. So we are copying here 09H interrupt in our AH register. And then with the help of load effective address dx comma message2, the address of our message2 will be added in our dx register. So now our contents of dx becomes 0013H. Then with the help of integer 21H interrupt, our data will be printed on our console. So our console displays that 8-bit number is. Now we have printed just this message on our console. We have not printed the value 23 on our console. So how it will be printed? So the next part of our code will display the 23 on our console. So the first one is we have to copy the contents of BH register, that is 23, in our BL register. So we are taken here BL is equal to 23, and our next instruction is we have to perform the AND operation, that is BL comma 0F0 with our BL register. So now we will check how this operation will be executed and what will be the contents of BL register after performing this AND operation. Now here the contents of our BL register is 23H. So our BL is equal to 23 and we have to perform the AND operation, that is 0F0. So we will discard this 0 and we can write it as F0. So in case of AND operation, first of all we have to write the BCD of that 23. So when we are considering this 2 as a binary, we can write it as 0010 and 0011. And for our F0, we can write it as 1111 and 0000. So whenever you are performing the AND operation, that time you have to check if 2 bits are 1, then you can write it as 1. And otherwise, all the bits will be 0. So you will get this result as 0010 and 0000. So after performing this AND operation with F0, we will get the higher nibble of our 23, that is 2 will be there in our result. So after performing this 23 and F0, we will get this 2 and this second bit will be discarded here, that is 0000, and it will become 0. So 23 is the result and that will be stored into our BL register. So now the value of our BL will be 20. Now the next line of our code is SHR DL comma CL. Now our contents of BL is equal to 23 and contents of our CL is equal to 04. So we have to perform the shift right instruction 4 times. So what is our instruction? SHR then 20 comma 04. Now we have to shift this 20 4 times on the right side. So for 20, we can write the binary it as 0010, then 0000. And we have to perform the shift right operation on this line. So now what will be the value after performing this shift right operation? In the first iteration, we will get this 0 here, then this 0, this is also 0, then this is our 0, then this is 1, then 0, then 0 and then 0. Second time, we will get this 0 here, then 0, this is also 0 and this is 1. Then 0, then 0, 0 and 0. In the third iteration, we will get this 0, then 0, then 1, then 0 and all these 0. And on the last iteration, that is the fourth iteration, we will get the value that is 0, then 1, then 0, then 0, and all these 0. So we will get the result it as this 0 and then 2. So for 0, 0, 0, 0, we will get this answer 0, and for 0, 0, 1, 0, we will get the answer 2. So after performing this shift right operation, the contents of our BL becomes 0, 2. Now you can check this output on our emulator screen. So I'm clicking on that single step mode of operation. So after performing the AND operation, the contents of BL is equal to 20, that is 20. And after performing the shift right operation, BL comma CL, our contents of BL is equal to 20 and contents of CL is equal to 04. And I'm clicking on that single step mode of operation, and you will get the result that is BL is equal to 02. Now we have to print this 02, that is 2, on our console. So how we can print this value on our console? Here we can check that our BL register is 02 and we have to print this 02 on our console. Our console will understand the hexadecimal value only. So that purpose we have to add 30 in our 02. So that's why we have right here add BL comma 30H and it will become now 32. So check that in our BL register the value is 32 and we have to display this 32 as a 2 on our console. But previously, before printing the data on our console, we need to put this value into our DL register. So we are writing here move DL comma BL. So now the contents of our DL becomes 32. Now here in our programming we have used the DOS interrupt, that is move H comma 02H. So this 02H interrupt is used for taking the data from the register and that will be printed on our console. So the register values are printed on our screen with the help of DOS interrupt, that is 02H interrupt. That time they will check the contents of DL register. Whenever you have to use the DOS interrupt 02H, that time you have to put the value in our DL register. So we have shifted here the contents of our BL to our DL with the help of this move instruction. And we are copying the content of BL into our DL register. So now our DL becomes 32 and with the help of this 02H interrupt, we are printing the contents of DL on our screen. So here the contents of DL is 32. That is the hexadecimal value of our 2. Whenever I am clicking on that single step mode of operation, it will display with the help of integer 21H and that will be 2 will be printed on our screen. So you can check that our 2 will be printed on our screen. Now we have printed 2 on our screen. Now we have to print 3 on our console. So how we can print the 3 on our console? So we will move to the next line of our code. So now again we have to copy the contents of BH into our BL register. So our original number that we have already stored in our BH register, that is 23. And that we are again copying it into the BL register. So now our BL register becomes 23. Then we have to perform again AND operation, that is BL comma 0FH. Now check that we are performing the AND operation with 0FH. So now we will see after performing the result what will be the contents of our BL register. Whenever we require the number that is 23 and from the 23 we require number 2, that time we have performed the AND operation with F0. That time we got the higher nibble from that number. Now we require the lower nibble from that number and we require this 3 here. So that's why we are performing the AND operation with 0FH. So for 23 we can write it as 0010, 0011. And for 0f, we can write it as 00001111. After performing this AND operation, we will get the contents of DL is equal to 0000 and 0011. Here both the numbers are 11, that's why we got here 0011. And now our contents of DL becomes 0000, 0011. So that we got this value 03. So now you can check this data on our emulator screen. So you can click on that single step mode of operation and you will get the result of that AND operation. And after performing the AND operation, you will get 03 in our BL register. So now we have to add 30 in our 03. So it will become 33. That is the hexadecimal value of our 3. So after performing this add BL comma 30H, the 30 will be added in our 03 and it will become 33. Now we have to copy the same procedure that we have already followed for our 2. So now we have to copy this 33 in our DL register because we have to print this value in our console. So how we can print this value in our console? So we have to copy this value into our DL register. Now the contents of this DL register will be printed on our console. But with the help of 02H interrupt, we can print this data on our console. Now the contents of DL is 33 and we are copying this value of 02 in our AH register. So check that our contents of AH becomes 02. So here the contents of DL is equal to 33, that is the hexadecimal value of our 3. When we are clicking on that single step mode of operation, then integer 21H line will be executed and it will display as 3 on our console. So now we have successfully printed this 23 number on our console. So that is the program for we have entered the 8-bit number and we are also displaying this 8-bit number. Now the next part of our code is .exit. So with the help of .exit, we can close all the segments that we have taken in our program. And with the help of end, we can end our program and our program execution will be terminated. So in this program, we have used the concept of DOS interrupt in our program. So the 09H interrupt is used for printing the output message on our console. 01H interrupt is used for taking the data from the keyboard and that will be taken the input from the keyboard. 02H interrupt that will be used for printing the register value on our console. So the output will be printed on our console with the help of register value. So these 3 DOS interrupt we have used in our program. So in this program, we have learned how to write an assembly language program to enter and display 8-bit number.